So another thing we might want to work or think about is evaluating functions. And so let's say you have a function of the form f of x is equal to x squared plus 1. Right. So what this is saying, when we write this notation out, what it really is saying is f is a function. And its rule is that it takes x and it sends it over to x squared plus 1. Now what's important here is that it doesn't actually literally do this, because x is not a number. X is a variable that represents all the possible numbers. And so what we're really saying, so what this is not an action on a thing called x, but a description of what f does to all the possible x's. So for example, what does f do to, let me label this whole thing f. What does f do to 1? Well, f should take 1, it should square it, and it should add 1. So 1 would be sent to 1 squared plus 1, which is 2. What should f do to 3 say? Well, 3 should be sent to 3 squared plus 1, which is 10. So that is the description of f and its action. And so what we would say here, for example, to evaluate that more specifically, f of 1 would be 1 squared plus 1, which is 2. F of 3 would be 3 squared plus 1, which is 10. And maybe as another example, f of 0 would be 0 squared plus 1, which is 1. So all that's happening here is that we are subbing in 1 in for x. So over here, I sub the 1 in for x as well. When I sub 3 in for x, I sub 3 here. When 0 it goes there, 0 goes there too. And so let's try something maybe a little more interesting. Let's say f of x is equal to x squared plus the square root of x. So what would f of 1 be? It would be 1 squared plus square root of 1. Again, this is a description of what's going to happen to the input x. So I put 1 in on this side. Then what's going to pop out is what this rule does to that 1, which is square it and add its square root. And you might have surmised that that is 2. So let's say, what's f of 0? Well, f of 0 will be 0 squared plus the square root of 0, which would be 0. So I take 0 here, and I send it there, and that's 0. So that's what happens there. And finally, let's try something like, what's f of negative 1? Well, it would be negative 1 squared plus the square root of negative 1. Well, negative 1 squared is 1 plus, but the square root of negative 1 is not defined, right? There are no real numbers that I can square that get negative 1. And so this leads us to an important discussion when it comes to functions, and that is on domains. The domain of a function is all the valid inputs. And typically, almost all the time, anything can be a valid input of a function. There's only two things that we don't allow. So the rule of thumb is 1 over 0, or really any number over 0 is bad. Alright, we don't want to divide by 0, and we don't want to take the square root of negative numbers. Right, those are things we can't do. We can divide numbers by any other number. We can divide 0 by numbers. We can take the square root of 0, and we can take the square root of all sorts of positive stuff. But these are the things that we should avoid. So So here's some functions here, f, g, h, and l, and I want to ask, what are the domains? So the first one, what f does is whatever the input is, that's going to be the output. Well, it seems like I can do whatever I want, right? If I plug in positive numbers, that's fine. If I plug in negative numbers, that's fine. If I plug in 0, that's fine. None of this kind of stuff is happening, right? So we could call the domain of this all real numbers, or equivalently, it's everything between negative and positive infinity. It's just everything in the number line. If I'm squaring a number, if g of x is x squared, then I have to ask myself, what numbers am I allowed to square? What numbers can I multiply by themselves? And I can multiply any number by itself, right? So it's really all the same stuff again. All right, 10 times 10 is defined, -4 times -4 is defined, 0 times 0 is defined. So all of those are perfectly fine. So you only really need to worry about the domain when we have square roots, or when we have stuff like this, when we have terms in the denominator. So for h of x, this x plus 1 guy here can't be negative. Right? It can be 0. So, right, the square root of 0 is fine, but the square root of the negative number is not okay. So, as long as if x plus 1 is positive, then that's perfectly fine. It's only that it can't be negative. So really, the domain here are any numbers where x plus 1 is bigger than 0. Or really, equivalently, as long as x is at least -1, right? If it's -1, then that sum is 0, and the square root of 0 is fine. If x is more than -1, then that's square root of a positive number, that's fine. It's only if x is less than -1 that's bad. So this domain is everything from -1 up until positive infinity. For this last one here, I can't divide by 0. That's my only rule, right? I can divide by negative numbers. I can divide by positive numbers. I just can't divide by 0. So as long as x plus 2 is not 0, I'm great, right? Well, that means that, this is a separate problem, that x can't be -2. Right? That's really what that means. If x is -2, then I get 1 over 0. Otherwise, that's a perfectly fine thing. So any number from -infinity up until -2, and then every number from -2 up until positive infinity Those are all perfectly valid answers to that.